going to show you how to integrate the Face API, how to get that running in the browser, and then connect that to Max MSP, and then be able to trigger events based on that from Max. So this video will consist of two parts. Part one will get the Face API up and running, and in part two, we'll actually make sure that we can talk with Max through Node.js. So to get started, what we need is this face-api.js page, and I've opened this up. I'll link it up in the description. And then on the desktop, we're going to make a new folder called face API. Like so. What I'm also going to do is download this repository, because I need the weights, the models that are stored in there. So I'm going to save it like this. Open that up, and then from that folder, I'm going to copy this other folder that's inside that are the weights of this specific network. So there's two parts that I need. So this is my new folder, right? Inside of that folder, I'm going to make a folder called weights, and I'm going to create a folder called JS, which contains my JavaScript. So the JavaScript part, what I'm going to do is in this downloaded folder, I'm going to choose the disk folder and then choose face API min.js. That one I'm going to move here. And then for the weights, those will be the parts of this trained network that I need. And there's a bunch of them, as you can see. The ones that we are interested in is this face expression model. Those are the ones that model the expression, but we can't use it as is. Face expression actually needs some other parts of this model. To start with, it needs to know where the face is. So it needs this either this SSD MobileNet or this tiny face detector. I've used this one, it works really well. So I'm going to copy and paste or move these ones over. Then it also works well on landmarks. So I'll use this tiny landmark model. So this one and this one. And this will detect the parts of the face. For example, the nose, the eyes, the mouth, things like that. And then finally, we can copy the face expression model. So that's this one. And that actually does face detection or the expression detection based on these landmarks and the actual position of the face. So that sounds like a lot of stuff, but in the code we'll make clear how we get through this. And actually the documentation for this is super well documented, so props to the guy here for actually making it like this. So what I'm going to do here is I'm going to open this folder up in Visual Studio Code. So I have my editor here, and I'm going to do open folder and actually select the folder that I just created. So it's in the desktop face API. So that's this folder. And inside of that folder, you'll find the same things that I saw before, but I'm going to add a file here. Specifically, I'm going to add an index.html file, so the start of my project. Okay, and then inside of this index.html file, I'm going to write my standard HTML. And because I'm using Visual Studio Code, I can just write exclamation mark and have emmet do the abbreviation, so it will do the rest of the document, and then do expressions. And then inside of the body, I need a couple of pieces. So I need a place where I can store this video, and that will be a video tag, but I'll do that inside of a video wrapper. And the idea is that we will have two parts overlapping. One is the actual video, so that's this video tag, and the other one is a canvas that allows me to draw on video, so I know where the landmarks are in the face. So I'm going to start a video. It's going to be auto-playing. It's going to be muted so that autoplay actually works. And on mobile, I also want plays in line. Otherwise, it will open this up in full screen mode, which is not what we want. Now I'll add a second element to that video wrapper, which is a canvas. And here I'll use the ID of overlay to actually draw on that canvas so I can see what the landmarks for that specific face that I'm detecting. I'll close off the div, and that's my video wrapper here. Let's get started with that part. So the only other thing that we need, and as you see, I have one div too many here. The only other part that we need here is a script tag referring to JS face API min.js, and then inside of that folder I'm also going to make a new file called expressions.js, and that will be my custom JavaScript file, and I'll link that here as well. So script source js expressions.js. There's a couple of pieces of styling that I need. I'm just going to add a style tag here inside of the header. One is that I want the body to be displayed as flex, and put everything in a column, and put everything in the center. So align items center, and use sans serif font. Very simple styling. And then for the video wrapper, this is really important. What I want here is to use position relative, so I can actually make these two elements overlap. I'll set the width of this video element to 500 pixels and the height to auto. And then for the video and canvas tag, I both want them to only be as big as the container, so max width of 100%. And then the overlay, so that's this specific canvas element. I don't want it to appear next to the video. Instead, I want it to appear on top of the video. So the video will be where it is, and this one will be set to position absolute with a top of 0 and a left of 0. That will position the overlay. Okay, now it's time to look actually in this expressions thing. So the first thing that I need is a way to access the camera here. And the way that I'm going to do this is I'm going to make a run function. So this will be an asynchronous function called run that will actually do all the work. And I'll call that function at the end here immediately. So the function is going to open the video, it's going to add that or start a video stream, put that video stream inside of the thing, and then also make sure that we load all the face API models that we just have these weights here. So there's a bunch of stuff that we want to do. Let's start with the video. So I'm going to make a video stream, and that's going to be const stream equals navigator, and we have to wait for that. Navigator media devices dot get user media, and here we're just going to ask for video like this. Now we want to be able to make that stream connect to the actual video tag that we have, and to do that we're going to select this video tag, and because we need it from other functions as well, we're going to put that at the top of our function. So this is going to say document query selector video, that's the ID video. And then while we're at it, we'll also select the overlay because we need to draw on that later. Query selector overlay like this. Okay. So once we have that stream, we have waited for it, we can say video.source object equals stream. So that's going to make sure that that stream is playing. And then once that's playing, we can actually detect that and have a function that actually started detection. We'll do that in a minute. Let's see if the video is playing first. So I have this live server inside of Visual Studio Code. If you don't have that yet, you can go to extensions and search for live server. That's the one that I'm running here, this one. And then I have this button here, go live, or I can also from the view menu choose command palette and choose live server, open with live server. Either way, that will start a server on this port, and here I am. Hi. So that's my video running, really nice. So now I want to be able to load those models from the Face API. Remember, we've already loaded Face API here, so we should be able to access that here. The way that that works in Face API is that we can use float from URI to load all of these different models. And it's always face-api.net. The name of the network, load from URI. So we're going to load these the three ones that we have. And the way that that works is we're going to put them in a promise.all. So in that way, all of the models load at the same time. So we're going to say await promise.all. So we're going to wait for that result to come back, and then only then continue with our video stream here. So we're going to say face-api.net. And then the first one is tiny face detector. And it's not a good idea to type these. It's much better to actually copy and paste these from here. And then choose .load from URI. And we call this folder not models, but wait. So we do /wait like this. And because this is a list, we can now load all the other models as well. So this is our first model that we want to load. Let's copy and paste that. And add commas here at the end. So because these are items in a list. The second model that we want to load, so we had this tiny face model here, is the face landmark, the small one, the tiny net. And then the last one is the face expression net, so this one. So these are the three models that we need to do, and it's going to load all of these weights. And we can actually see that if we open the inspector here. we look at the network tab, we refresh, we can actually see that it's loading these little models here all at the same time actually. So that's really useful. And then we know that these are loaded because we've done that. We know that our video stream has started, and then once it's actually playing, we can listen for a play event, and that will actually start off the detection. So we'll add a detect method, and we'll add that here. So the detect method is also an asynchronous function called detect. And what that's going to do is it's going to call face-api. And as you can see here, there's a bunch of ways that we can do this. In this case, we're just going to detect a single face. And with that single face, we're also going to detect face landmarks. And with those, we're also going to detect face expressions. So something that looks like this, although we'll need a bunch of properties here as well. So we're going to write face-api, and wait for that, face-api.detect single face. It's going to get that data from the video. That's the reason why we have this video here at the top and not only inside of this run function. And it will need some options. And we'll leave those out, and I'll show you what the problem is if we don't have these. So we're going to store these in results. And now we'll see that we get an error here. It says SSD MobileNet load model before inference. So it's looking for the SSD MobileNet. We haven't loaded that one though. We have loaded this tiny face detector. And to make sure that we actually can use this tiny face detector, we have to add a property here. Specifically, this one's mentioned here, tiny face detector options. Detector, right, these ones. It was actually mentioned here that this is the way that you actually detect it. So the options specifically allow us to make a smaller input size, and this is really useful if you're working with a slow computer as I am. So we are going to set an options object here, face detector options equals new face-api tiny face detector options. Again, it's not a good idea to type these, you probably should copy and paste those. And there's one thing that we want to do is set the input size. As you can see here, it must be divisible by 32. Common sizes are 128, 160, and so forth. I found that 160 gives the best results, fastest at least. So that's the one I want. So here, whenever I'm detecting a single face, I'm going to add that option, face detector options, and that's going to detect my face. So now, at least it doesn't crash anymore. It also doesn't show anything, but it doesn't crash. So we can log out these results. Yeah, and it's doing that once, giving me an undefined error. But now the idea is that I can keep doing that. So I can say request animation frame, because I've waited for these results. I can just keep on detecting. So now the next time it's going to detect over and over and over again. So the first time it might say undefined, but after that it's going to give me all of these data, which is super nice. Okay, cool. So, but we're not done yet. We detected the single face, but we need something else as well. We need to get the landmarks here. So we can use with face landmarks, this one, and then also with face expressions. Now the with face landmarks function here actually also needs an option, and that's whether we use the small one or the large one. And I can just put true here, but I'm just going to say const face landmarks tiny model equals true. So I'm going to give this a name, so it's kind of clear what this true actually means. It could just say true, that will work as well, but having this word in here makes it clear that this is what is signifying. And the last one with face expression doesn't actually take any options, so it's just with face expressions. And you'll see once we do that, that the results actually change. So there's more stuff going on. You can see that in a minute. So the first one is always going to say undefined, but then afterwards you see that we have the landmarks. We also have the expressions. So here we have expressions, neutral, happy, sad, and so forth. So there's all this really useful information that we want to get back. And we can draw that. So now we can say, well, we don't want to log it, but every time you have results, and those results contain the expressions, then we can actually draw these things. So then we can say, okay, draw these. And because we don't really know the size of this thing, we have to make sure that both sizes match. And the way that we do that is we use their own drawing API. So there's a match dimensions, and then we can resize these. So that's what we're going to do. So we're going to say const dims for dimensions is face-api.match dimensions. It's going to match the dimensions between the overlay and the video. Once we have those, we're going to resize our results so that they actually match the size of the video or the size of the overlay. So resize results. So give me the results and give me the dimensions. And then I can do face-api.draw detections. So that's where are the faces located with the resize results. I can also draw the landmarks. Draw face landmarks. Again, on the overlay with the resized results. So that's almost the same. And then finally, I can also just copy and paste this line. Draw face expressions. And here I have to add a last parameter, which is how short you want to be. So 0.05. So the very small expressions are not detected here. So now I should be able to see my own face. I will see a box around it indicating where I am. And then I will also see the landmarks and the expressions if all goes well. And I hope it does. Yep, there we go. So that's my face. See, it's neutral, happy, sad, angry, all of these emotions at the same time. So that's it for part 1. In part 2, I'm going to cover how to connect this to Max MSP so I can actually get that data that we see here inside of Max.